All right, let's take a look at our lesson on properties of exponents. Now, a lot of this should be familiar to you or a review. You would have covered, some of this in Algebra 1, but it is so important. Properties of exponents, they are the source of many errors, so I don't want that to happen to us. So let's kind of walk through the laws and make sure we understand what to do. So if we have common bases and we're multiplying terms with common bases, we're going to add the exponents. So some teachers have this little saying, base, base, add. I don't know if that's helpful, but so common bases that you're multiplying, you would add the exponents. Common bases that you're dividing, you're going to subtract the exponents. Okay, so that's multiplying common bases and dividing common bases. Now let's look at another scenario where we're actually raising some individual terms, whether they're variables or numbers, to a particular power. Since these are being multiplied, what the rule tells us to do, and this is to the first power, this is to the first power, what the rule tells us to do is to power to power is multiplying. So we would distribute that power to each of the objects inside that parenthesis. Here's another scenario where we've got something other than a 1, some other variable. This is, so I call this power to power. And when we have power to power, we multiply the exponents. Okay. All right, so here, very similar to this example where, or the rule actually, these are the laws. This is to the first power, this is to the first power. So we would distribute that exponent to each of those powers, which would give us a to the x over b to the x. Okay, that's a thing. Now, let's be sure we recognize that these exponent rules do not work. So let's go back to this one. This exponent rule does not work if I had something like, let's say we had a plus b to the x. That does not equal a to the x plus b to the x. That's a huge source of mistakes for students. So that does not equal. So that is a big no. It's a big no, okay? Big no. We can't do that. Okay. All right, so likewise with this, if this had been, a plus b over, say, c plus d all to the x, that would not be the same as a to the x plus b to the x over c to the x plus d to the x. That is not something we can do. So what ruins all of our fun? The adding and subtracting. I mean, this right here, this stuff right here makes it to where we cannot do those kinds of things. Okay, that is another big no. Okay, so let's talk about negative exponents. So negative exponent can be rewritten like, if I have x to the negative y, then I can certainly rewrite that as 1 over x to the y. And what that does for me is it gets rid of the negative exponent. Many times we don't want negative exponents in our answer, so that's something that we would want to do. But again, we have that scenario where we've got, let's say we have something like this. Let's say we have x to the negative y plus 1 over, say, 2 plus x. Okay, so in this case, I am not allowed to bring that down to the denominator because, again, I've got a plus here. So that just, again, ruins our fun. Okay. So hopefully that's helpful. Let's, I want to be a little bit more specific on the x to the negative y's. So we've seen this scenario. What if we had, let's say, 1 over x to the negative y? What would we do? Well, that would turn into, that rule would give me just x to the y. I know that's hard to see there. So, so what you can think of, like in a practical manner, is if you have a negative exponent that's not attached by by addition or subtraction, you can change the positive to negative, or negative to positive of the exponents by moving it. If it's in, say this would be similar to the numerator, then we move it to the denominator to cause the exponent to be positive. Or if it's in the denominator, we move it to the numerator to cause the, in this case, the y to be positive, and y for the other one as well. So that's a breakdown on all the rules. Now let's do some practice. Let's do some practice of these rules. So these are common bases, and I'm multiplying. So it's this first rule, base, add. So this is going to give me, and I'll write it out, you don't have to, we're going to add those together, x to the 3 plus 5, which would simply be x to the 8th. Okay. Here we have common bases, and we are dividing. So again, I'm going to write it out using the rule. So the rule tells me that I would do 46 minus 33, and 46 minus 33 is, what, 13. And so that would be the simplification of that example. Okay, one more on this page. So what I always like to do first is I like to deal with the negative exponents first. I just do. I want to turn them to positive exponents. I don't want to try to just use the rules and everything. I want to really understand what's going on. So I'm going to rewrite it. The first thing I'm going to do is I'm going to rewrite it with, I'm moving the y to the negative 4th to the bottom, the denominator, so it turns into y to the 4th. Okay, and we can do that because there's no adding and subtracting in here. There's nothing going on. It's multiplication, so that's an okay thing to do. All right, so that leaves me x to the 23 over y to the 4th, y to the 5th, x to the 30th. All right, now what I want to do is combine together the bases that are common. So we can see that these bases are the same. I can bring those together, and these bases are the same. I'm going to bring those together. So let's do the y's first. Those are easier. So I'm just going to, and again, you can do them all at once if you want to. So base add, so 4 plus 5 is 9. So this would be y to the 9th, x to the 30th. Now, we can use the rule, which actually can be a little confusing in this case. I guess I'll show it to you both ways. What I would like for us to think of first, just intuitively, I have 23 x's in the numerator, and I have 30 x's in the denominator. And if I were to write them all out, write them all out and cross them out, what would I be left with? We don't really want to write out 23 x's and 30 x's. I don't know, maybe like on Friday night, if you don't have anything to do, maybe you want to do that, write out 23 x's and 30 x's and then cross them off. But instead, let's kind of use our minds to think, what would that become? Basically, the 23 x's in the numerator would cancel with 23 of the x's in the denominator, and it would leave 7. So thinking of it intuitively like that, I basically have this scenario. Now, it doesn't really matter if you write the y first or the x first, whatever you want, it doesn't really matter. So let me explain why I was saying the rule is a little confusing, because the rule would tell us to do x to the 23 minus 30, right? And that gives us x to the negative 7. And you're wondering, what in the world? What do I do there? That just means that this would be x to the 7 in the denominator. That's what that would be if we were able to use the rule. So that's the scenario with using the rule. Okay? All right. All right, so let's go to the next page and work some more examples, just to kind of make sure we're really understanding what's going on. Okay, so we've got power to power going on here on number 4. So I'm going to rewrite this. I'm going to take this exponent and distribute it to each of the exponents. So I got x to the 21st, because 1 times 21 is 21. And then I've got y to the 3 times 21. So that gives me x to the 21st, y to the, let's see, 3 times 21 would be what, 63. And that's our example. Okay, let's look at number 5. Okay, this is a 1 and this is a 1. All right, so I'm going to distribute as power to power. There's no adding and subtracting inside there. So I'm going to distribute this, and that gives me 3 to the 4th, a to the 4th. Now, if it's a number that you can actually multiply out without too much trouble, I mean, I wouldn't want you to try to calculate 3 to the 25th power. I mean, that would be really crazy without a calculator. I'm talking about in your mind, right? We should be able to do some stuff in our brains. So what we would do to do 3 to the 4th, one way to think about it would be, well, what if that was 3 squared times 3 squared? Okay, I know, so this is just what I would think. Just what I would think when I'm going to, you know, get an actual number instead of that. 3 to the 4th is, it is possible to turn that into a plain old number so we know what it is, right? If I told you to go to the store and get 3 to the 4th of, I don't know, tomatoes, you'd be like, what? So we just want to clean it up. So 3 squared, that's 9, and 3 squared is 9. So basically 3 to the 4th is 81. 81, 8 to the 4th. Okay. So let's work on number 6. Again, we've got power to powers going on right here, and we have multiplication going on. So let's do our power to powers first. M squared to the 2nd power. So again, power to power, I multiply the powers, I get a 4. And then times m to the negative 2 to the negative 2. So negative 2 times negative 2 is 4. And so now I have base add. See that now? I have base add. So m to the 4th times m to the 4th. So that would be m to the 4 plus 4, or 8. I hope you can see how totally confusing this could be if you don't have the rules like down solid. And you've got to have them down solid, or you might think, oh, well, that's m to the 16th. Well, no, it's not, because they're being multiplied together. The common bases are being multiplied together. It's not a power to power scenario. So just be cautious. Here, it's a power to power. All right, I'm going to multiply these two together. Now, the square root of 3 times the square root of 5. So since they both are under the same type of root, which is a square root, I am allowed to bring them under the same root. So that's the square root of 3 times 5, and its most simplified form would be the square root of 15. That's unusual, isn't it? Strange looking. Okay, so that's where jumping into radicals. Woo. Okay, number 8. Let's see, we've got base, a common basis we're going to add. So this would be 3 to the square root of 8 plus square root of 2. Now, unlike multiplying radicals like we did down here, you know, down here was the whole multiplying radical thing where we could just, you know, multiply them together. That's not the case with adding. You know, adding is just much more fussy, isn't it? That is not the case with adding. So what we have to do is get, I would need a square root of 2 to be able to add to a square root of 2. Like, for example, this is just a side note. If I had like 2 square root of 2 plus square root of 2, I treat square root of 2 kind of like a variable. I don't really mess with it. I have 2 square root of 2's plus 1 square root of 2. That would give me 3 square root of 2. Okay, that's just a side note on how to work with adding, you know, adding these little radical guys. Okay, so to be able to work with this square root of 8, I'm going to have to do a factor tree. Remember, we probably remember that from a while ago, right? Yay, factor tree. The square root of 4 is 2. So this is 3, 2 root, and 2. There's an extra 2, so I leave it inside. Oh, isn't that weird? I get the same example. 3 to the 2 root 2 plus 1 root 2 gives me 3 to the 3 root 2. Okay, that was fun. All right, our last one. Oh, goodness, look at that. I've got power to power all over the place, right? All over the place. I'm going to do all my power to powers first so I can get rid of the outside parenthesis, and then I'll start working on the inside. So, okay, here we go. So x squared to the 4th would be x to the 8th. Y to the negative 4th to the 4th would be y to the negative 16th. Then I have x cubed to the 4th would be x to the 12th. And y squared to the 4th would be y to the, 8th? Okay, we got rid of our outside parentheses, yay. My next step, what I would do is I would deal with the negative exponent. So I'm going to rewrite that. I'm going to leave x to the 8th in the numerator. Then I've got the x to the 12th and the y to the 8th. And then I'm going to take the y to the negative 16th, put it in the denominator to make it a positive 16. Yay. Okay, again, we're matching bases. We're going to deal with these two. We're going to combine those together. And we're going to deal with these two. We're going to combine those together. All right, so let's do that. Let's do it all at once. Ooh, wouldn't that be fun? All right, so I have 8 x's in the numerator and 12 x's in the denominator. Let's see, that leaves me, what, 4 x's in the denominator. Okay. Then I have 8 y's and 16 y's, so base, add. So 8 plus 16 is, what, 24. There we go, and there is our lesson on exponents.